So in this video, I will be discussing Codeforces around 986. So I will be discussing first three problems of this set. Let's start with problem number A, that is allies adventure in chess. So we are given initial position of allies, that is 0, 0, and position of a red queen, that is A, B, and they are all plotted on a grid. Okay, now we are also given directions of allies, that at each point in which direction allies will go, and represents north, east, south and west. Now we have to tell them after some certain number of moves will allies be able to reach the red queen or not. And if the string is occupied, like if you have run all of the steps in the string, then start again from the zeroth index of the string, right? So whether he will be able to reach uh, red queen or not in infinite number of steps. So print yes, else print no. So if you notice, the length of string s is just barely minimum, that is only 10. Okay, so if you repeat the operations at most 100 or 1000 times, and you didn't reach the index a comma b, then in that case answer is no, else just print the answer yes. So I think so there's no need of showing the code of this problem. So let's start with problem number A, that is Elite's adventure in permutation. So in this particular problem, we are given three integers a, b, and c. Okay, and array a is of length n, and we are also given a of I is equal to b into I minus 1. So this is one base indexing. So for ideally zero base indexing, we can consider this as a b into I plus c, which means a of I is equal to b of b into I plus c. Okay, now we have to tell them whether we be able to convert the array into permutation or not. And what are the operations given to you? We can just choose a maximum element of A and replace that maximum element with the max of the array. Hope so you know the max definition. This is also given the definition of max. We have to replace the maximum element of A with the max of A. If there are multiple maximum elements, just replace the leftmost and replace it. Now we have to tell them what are the minimum number of, or what are the number of steps. By performing operation on this particular array A, you will be able to get a permutation which is from 0 to n minus 1. Notice that usually the Codeforces give you permutation from 1 to n, but in this case it is 0 to n minus 1. So what are the number of steps in which you will get a permutation of 0 to n minus 1? So how to solve this problem? So to solve this problem, just break it into some parts. Okay, the parts are written over here. I will explain you. Okay, so what is the condition? Condition was b into I plus c is equal to a of I. Okay, this is the only condition given to me, right? So if I consider some cases, if b is equal to 0, if b is equal to 0, then all the numbers will be equal, right? Then all the numbers will be equal, that is equal to c. Okay, done. But if I tell you that all the numbers are smaller than n, if all the numbers are smaller than n, for example, my c is, let's suppose my n is 5, and my c is, let's suppose, 2, then my all the numbers will be 2. Yes, 2, 2, 2, 2. So tell me, can you make it as a permutation or not? So the answer is no. But why? For example, the max in this case is 0. Just replace the minimum with 0. Okay, done. Done. Now in this case the maximum is 2. Just replace the maximum 2 with again the corresponding one, because 1 is now max of the array. I will replace it. Now again max is 2. Replace 2 with max. What is max? Max is 3 in this case, right? Just erase the 2 and write it 3 over here. Done. Now tell me, what is a max? Max is 3 over here. Right. Max is 3 over here. Just replace the 3 with 5, 4. Now you notice one thing. Your 3 is vanished. There is no more 3 in the array. So if you repeat the operation, your 4 will be replaced by 5, and you will never get the remaining numbers, that is 3 and 4. So in this particular case, answer is always no. Alright. Okay, just print minus 1 if b is equal to 0 and c is smaller than n. Now another case. If c is greater than n, then what is the answer? If c is greater than n, which means your, let's suppose n is equal to 5 and c is equal to 7 in this case. So 7, 7, 7. Okay, done. Now you know one thing, that all the numbers are greater than n. Yes. So you will minimum to minimum require n minus 1 operations Yes or not? Yes. You will require n minus 1 operations at most minimum, right? So if you start making the operations, that is replace largest by max, that is 0, replace largest by max, that is 1, again 2, again 3, again 4. How many operations do you need? That is 5. What is 5? That is n. So if your n is smaller than c, then just print n. If your n is greater than c, just print minus 1, because in that case you cannot achieve the permutation given to you. But this is the only case when b is equal to 0. When b is not equal to 0, then what you will do? I will tell you here. So if b is not equal to 0, then you have to calculate. For example, I will take example of n is equal to, let's suppose n is equal to 5, b b is equal to 2, and c is equal to, let's suppose 3. Oh, okay, let me take a smaller number, 1. My c is equal to 1. Now what is my array? Array will be 1. Now again will be 2, then 3, then 2, 4, 5, and that is um, 0, 1, 2, 3, 6, 7, 0, 1, 2, 3, 4, 8, 9. Okay, done. Now if I tell you calculate the numbers which are greater than n, which calculate the numbers which are greater than n. Okay, in this case these are number which are smaller than n, and these are number greater than n, right? If you calculate the numbers which are greater than n, then these are the number of operation which will be required to make the max. If you are confused, then I will show you. For example, the max in this case is 9. Oh, the maximum number is 9. Just replace 9 by 0. Okay, now what is the maximum number? Maximum number is 7. Just replace 7 by another max, that is 0 is covered, 1 is here, 2 is left. Replace it by 2. Okay, done. Now this is also greater than, so the array will be this only. What is max? Remove the 5 and replace it by 4. So the numbers which are greater than n, greater than equal to n, are the number of operations which you will be requiring to make the permutation from 0 to n minus 1. The logic is simple also. The logic also simple, because these are numbers which are greater than n, and you will add them will be replacing these numbers which are not in the range of 0 to n minus 1, because these numbers are already in the range of n minus 1, but these number are greater than the range of n minus 1. So at some point you will be replacing these numbers with the numbers which are coming in this range. So this is the only logic. But how to find? So this is this very simple equation. So what is the equation given to you? Equation given to you was b into I plus c should be greater than n, because these are numbers which will be greater than n. And if you replace it with this particular condition, you will get upper bound of n minus c divided by b. Yes, this is ceil function, right? So just find this particular ceil function, and these are the numbers which will be greater than n at the end, right? And just print this, because this is the only answer. If I show you the code is also pretty much easy. These are the condition for b is equal to 0, right? And after that you will print n minus 1, or this is the numbers which will be greater than n, and that's how print the answer. And that is how you will solve the problem b. Let's now discuss problem c, that is Eli's adventure in cutting the cake. So this is the very, I think so, implementation based question. But what is the question? Eli's is Eli's is in a tea party. Okay. Now there is a long cake which is made up of n sections. Okay, done. And the tastiness of each section is a of I. Okay, done. A of I, b of I till a of I, a of 2 till a of n. Okay. Now there are m creatures at a tea party, excluding Eli's. Now we have to divide the particular cake into m plus 1 pieces, because m pieces will be for the creatures and 1 piece will be for the allies. Okay, done. You can see the definition over here. She will partition the cake into m plus 1 subarrays, where each subarray consists of some number of adjacent sections. Okay, done. Now the testiness of the piece of the sum is defined as the sum of the pieces. Okay, done. Now for the creatures there is a condition that for the creature to be happy, the testiness of that particular piece should be greater than or equal to v. V is given to you. Now there is there is also a condition. She can also divide the particular cake into m pieces because Alice does not want cake to be with her. Okay. Now, to make every creature happy, by the limited condition, she also wants to maximize the tastiness of her piece. Can you help Alice? Which means the first condition she had to satisfy the tastiness of each creature should be greater than V. If this is satisfied, then she will focus on her tastiness because she wants the maximum taste. Okay. Now you have to print the maximum tastiness which Alice can get. Okay. If there is no way such that all the creatures will be happy, then just print -1. So I will tell you the problem with an example. So this is a particular case which I will be debugging. Okay, done. So in this case, I will be considering some prefix array and suffix array also. So array given to me is 1, 1, that is 10, that is 1, that is 1, and this is again 10. Now I will maintain two arrays. What I will maintain two arrays. One is, let's suppose, front sum. I will explain the later definition later. That is front sum and the last row and the last selected of the front sum. Okay, done. So in this case, the array of this particular array would be only m. That is the number of creatures. In this case, the number of creatures are, I think so, two only. Mm, let's suppose increase the number of creatures to, let's suppose, 3. Just for the sake of practice only, I will increase the number of creatures to 3. And the third number is v, and I will increase this to 3. Let's suppose 4 only. Okay, so the number of creatures are, let's suppose, 3. Okay, just a second. Let's suppose the number of creatures are 3 and including less, there will be total m plus 1, which means 4 pieces. Okay, done. Just make an array of size 4. Okay, done. I will be making two arrays, that is for the first sum and the last selected. Okay, last row selected. That is 1. That is 2. That is 3 and 4. Okay, done. Now for each and every next what I will be storing. I will be storing, is my current creature happy or not? Okay, is is my current pointer happy or not? Okay, done. But how? I will maintain a counter, that is for just start counting from the first and stop when your sum is greater than or equal to v. Okay, at this point your sum is greater than or equal to v, that is 2. Okay, done. What I will show here, that is first sum will be containing 2 because this will be the sum. Okay, done. And what will be the last row containing? The last row will be containing the index where it has been stopped. Where it is stopped? It is stopped at index 0, 1. Okay, 1. Done. Now where is the next stop? Next stop is only 2 because 10 is greater than 2. Okay, I will maintain this. But I will store here. I will store 12. Just sum of it. I will explain you the intuition later. Just understand this implementation. Okay, store the sum in the next point where it is stopping at 10. What I will show here, the prefix sum. Just add back plus current sum, that is 10. Where it is stopped? It is stopped in index 2. Okay, done. Now what is the next point? That is 1 plus 1, 2. What I will show here, 14. And here 0, 1, 2, 3, 4. 4 over here. Now next is 10. I will show 24. And what I will show here, that is 5. Okay, done. Similarly, I will create another array. I will create another array, another two arrays, sorry. Okay, and what will that two arrays containing? That two array will be containing the similar array, the similar logic array, but in the reverse manner. Okay, but how? How part is simple. Just I will tell you the implementation. What is 10? First is 10. I will store it 10 over here. Again is again 12. Now it is 22. Now it is 24. Okay, done. And what the last index is? Where my 10 is ending? At point 0, 1, 2, 3, 4, 5. At index 5. Where is my 1 ending? 0, 1, 2, 3, 3. Because you will notice these are not same because this is in the, okay, this is in this manner, but this is in this manner. For this particular reverse array, my one sum is ending at this point because I'm calculating from the right to left. That is why 3 over here, not 4. For the 10, I will store again 2, and for the 1, I will store 0. Okay, done. After creating these four arrays, what I will do? I will run a loop. I will run a loop from 1 to what is my key? That is 3. Okay, done. For each and every index, I will check whether it is satisfying or not. Whether my first sum is satisfying the last sum or not. But how? What I'm trying to say, you must be confused, but I will tell you. So what was my goal? To to accumulate at most three creatures, right? To accumulate at most three creatures. Okay, done. So if I choose one index from this, okay, done, and one index from this, okay, you know one thing, that here my two creatures are completed over here, right? My two creatures are completed over here, and my three and my okay, my one creature is completed in this array, and my another two creatures are completed in this array. Okay, let me just change the color. My one creature is been completed by this. Two creatures are been completed by this. What is total sum? 1 plus 2, that is 3. 3 creatures has been completed. Yes or no? The answer is yes. Okay, done. 3 creatures has been completed. But what I will do now? I will just find the sum which has 2 over here. Okay, what is the prefix sum over here? 2. Which means in the left part of the array, the sum of the creatures was 2, and the left part of in the left part of the array, the sum of the creatures was 12. Yes, plus 12, which means this much tastiness of the cake has been occupied by creatures only, so what is left with me? The left with me was sum of this particular array, because that is a full tastiness. The sum of the array minus the current prefix which I get, that is 14. Okay, done. But this is only one case. This is only one case. But what is it signifies? Which means LIC is taking this part, and this part are taken by creatures. Right, right. So hope so it is clear to you what I'm trying to say over here. Okay, done. Let me erase this part. Now let me take another example. Okay, done. So let's suppose now LIC is taking this much array. Okay, now the creatures are taking this much array. Now tell me how many creatures are already been covered. The 3 creatures are already been covered over here. What is the sum? The sum is 14. Again, s minus 14, and the remaining sum would be for LIC, that is 10. But now you will ask, what is the role of this particular second array? The second array will come in place. I will tell you why. For example, now you will try to consider this array. Okay, done. Okay, now two creatures are covered by this. Yes, two creatures are covered by this. Okay, done. Let's suppose there's a hypothetical case. This is hypothetical. Not I'm not talking about this case. Let's suppose this sum is covered by two only. Okay, done. And this is also two. Let's suppose this is two over here. Just suppose this is a case. This is two. I'm sure that this is not two in this case, but let's suppose it is two. So two are two creatures are covered by here, and one creature is covered by here. But you will notice one thing: these two creatures are being covered on the same index, which means if I'm able to cover front array in this manner, then my last array is also covered in this manner. But now you will ask me, is there any space left for allies to come over here? There is no space left for allies to come between over here. So you have to make a check. You have to make a check. What is that particular check? The check is similarly for the last and the front row. Uh, just says to just says to after checking the sum, you have to also match that the last row should be smaller than your for this particular last row. The last row of first array should be smaller than the last of next array, because that is the space which will be occupied by LIC at 10. For example, this is 2, this is 5, this is overing over here, like this is completing over here, and this is completing over here, which means this space will be occupied by LIC. This space will be occupied by LIC. which means you have to check the condition that this particular index should be smaller than this particular index. Hope so it is clear to you, and I will show the implementation. Like first of all, just find the sum of the whole array. Okay, done. Find two, just create two arrays for the, I'm now creating these two arrays, that is sum front and the last end. Okay, done. I'm iterating m times. Okay, done. If at any point my sum, I'm like calculating the sum, if I am able to get a higher sum than v, then I will assign the sum front as sum front minus 1. I will tell you that the prefix sum which I am taking, the sum front minus 1 plus the current sum, and assigning the last end, which means the current, the second array, to the r minus 1, because I have increased in the pointer, that's why I'm making the r minus 1. Else I will assign a higher value because I will not consider this value at anymore. Okay, done. And similarly for the prefix sum, like the suffix sum from the end, I'm making the current from the end, this is a right pointer, I will decrease the right pointer. You can see I'm decreasing the right pointer, assigning to the left and decreasing it. And at what point I will decrease it, till my current sum is smaller than v. If my current sum is greater than v, then I will just add it and assign it to the this particular array. Done. Now after creating these two arrays, just check if my front sum is not equal to, like these are the condition which will be telling me whether which will be telling me whether I was able to achieve a sum or not. Okay, I was able to achieve achieve the sum. Now second condition will be my last end should be smaller than my first chart. Okay, which means my this array should be smaller than my this particular index. If these conditions satisfy, just find the sum. Just find the prefix sum which I just told. That is this particular sum and this particular sum. Find the sum, subtract it from the whole array because that is the sum which will be left for the arrays. And the maximum for all these cases will be final answer. So if you have any doubts in any of these three problems, just comment me down. Till then, stay tuned for the next one. Thank you.